This is the video lecture for the first part of Chapter 2, Kinematics in One Dimension. In this lecture, we will look at speed and velocity, covering both average speed and instantaneous velocity. Displacement is a vector quantity that measures both the magnitude and direction between an initial position and a final position. The displacement is a straight line between the 2 points, covering the shortest distance. We draw the displacement as an arrow with the tip pointing towards the final position. We will use meters to measure displacement as a function of length. It is important to not confuse displacement with distance, because distance can be the distance traveled, whereas displacement can actually equal to 0. If you were to start standing in a position, walk forward 2 meters, and then walk backwards 2 meters, you will have traveled a distance of 4 meters, but your displacement would be 0. The amount of distance covered in a certain amount of time is known as the average speed. For example, if you covered 10 meters walking very fast in 2 seconds, your average speed during that time would be 5 meters per second. Average speed is a scalar quantity because there is no direction associated with it. It only involves the distance. You can't have a positive or negative average speed. That would be a velocity, as we'll talk about in a second. Once again, it's a scalar quantity, just magnitude or size. The units for speed are meters per second. This is a length divided by time. One thing I would like for you to do in your notes is on the highway, the speed limit is generally 65 miles per hour. Please convert this into meters per second. Make sure to show all your work and include this in your notebook. Velocity is the rate at which position changes. Think of any rate as something that depends on time. In your job, you get paid an hourly rate. This is money per hour. Power is the amount of energy consumed per time. Power is the rate that energy is transferred. Velocity is how much your position changes per unit of time. For this, in order to calculate it, velocity V is the representative symbol for that. And we say it's the average velocity, so we have a bar above the V, is found by using the change in position. This is, in this case, we're just looking at one dimension. So the change in X, this is delta, represents the change in symbol. So it says the change in X divided by the change in time. Average velocity is a vector quantity in that it has both magnitude and direction. The direction comes from the displacement. The units for average velocity are meters per second, and this is a length divided by a time. If I wanted to say a speed, all I need to do is give the magnitude. For example, 65 miles per hour. However, if I want to have a velocity, I need to make sure to include the direction. So 65 miles per hour converted into meters per second would be 29 meters per second east for the velocity, if I was in fact actually traveling in an eastward direction. One thing to think about is, what about the average velocity of a person running on a circular track? If their starting position is the same as their ending position, have they any displacement? In this case, the answer is no, and so their average velocity would be 0.